For our EC528 cloud computing project, we were assigned IBM's open source Autopilot dashboard. There comes many problems when running AI workloads on clusters. Running a system to monitor AI workloads is crucial due to the complexities involved with managing resources, optimizing performance, and ensuring reliability. These challenges include resource contention. Clusters often face issues where multiple workloads compete for limited CPU, GPU, and memory resources. This can lead to performance of degradation or job failures if not managed properly. Visibility and monitoring. Inadequate monitoring tools can make it difficult to detect and address issues such as network latency spikes, disk I/O bottlenecks, or hardware failures promptly. And this can impact the reliability and performance of the AI workloads. And manually scaling processes, they can be very time consuming and error prone. This can hinder the ability to effectively expand or contrast cluster resources in response to workload demands, and this can overall affect performance and resource utilization. Introducing IBM's Autopilot, we are essentially just building a UI on top of what the IBM engineers have already built. Autopilot is supposed to provide continuous monitoring for GPUs, networking, and storage health within Kubernetes clusters. It implements a variety of many health checks, including subtle software issues and connectivity tests, and it ensures a robust system evaluation and proactive issue identification. Optimized resource management, it is deployed as a Kubernetes daemon set on GPU-equipped nodes. Autopilot optimizes resource allocation without required privileged access to GPUs, thereby supporting efficient AI workloads, execution, and scalability.
Currently, the biggest problem with Autopilot is its lack of visualization in UI. Autopilot gives all of the needed information for health checks on nodes of the cluster, but it doesn't have an easy way to see the data. The current implementation is only through command line. Some issues with this are that engineers can be overwhelmed with the amount of data shown in text. This causes parsing through all of the cluster data and troubleshooting to be more difficult. Running health checks requires manually entering nodes and parameters, which is time consuming and could lead to human error. For these reasons, we think it will be beneficial to implement a UI. Our vision for the project is to create a UI dashboard which operates with OpenShift and Kubernetes clusters. The key features of our vision are real-time cluster and health check monitoring, an embedded terminal to see the results in the dashboard for better interaction, and an intuitive interface for easier management. Our goal is to provide clear and understandable information about the performance and health of clusters, as well as help admins by improving their responsiveness, visibility, and control of the system.
We want to talk about the users of this project. IBM Autopilot is designed for someone who needs to run AI workloads and detect the infrastructure level issues for these jobs. IBM Autopilot will also be used for anyone who requires health checks on the system. IBM Autopilot realizes these purposes by continuous monitoring and evaluating hardware and devices such as network, GPUs, and storage. Now, here are two examples corresponding to these two purposes. The first example is a data scientist called Martin. As a data scientist, his daily task involves processing large amounts of data and performing complex computations. One good example would be training deep learning neural networks. Martin submits a training job that makes weeks to run. It would be beneficial for him to have an interactive dashboard that allows him to monitor the status of his training jobs, including the status of the cluster and the requested GPUs. He would be notified when there's an error and get the problem solved by himself. Another example we want to tell is the administrator called JC. As a system administrator, JC is responsible for managing and maintaining a computing cluster. Her main task includes ensuring health and performance of hardware resources such as GPUs, network, and storage systems. She runs health checks with detailed diagnostic tools and fixes them when notified. In other words, JC would be notified by Martin to resolve his training job issues. JC would need an interface that allows her to review Martin's computing cluster usage and carry out detailed diagnostics to resolve Martin's problems.
Let's talk about the scope and features of this project. Some of the features that we have in scope are an embedded terminal, which will display the results from autopilot testing when requested. We will have our dashboard overview, which provides real-time insight into the health and performance of the Kubernetes clusters. We'll have a monitoring page and a testing page, where the monitoring page will contain lists of all the nodes with a drop-down list of statuses you can select to filter out different nodes. The testing page, you will be able to select nodes and run different tests. A stretch goal that we have is to implement a recent test history, where you will view the details of recent tests and it'll allow users to quickly rerun the tests without going through backlogs. One feature that is not in scope is improving upon Autopilot itself. Autopilot is already a fully functional Kubernetes daemon, and our goal is to make it easier to use and more accessible through our UI dashboard.
So here is the architecture for our application. We have an active Kubernetes cluster running an AI workload. Of course, we have Autopilot running on this cluster as a Kubernetes daemon set. And here is our application, the Autopilot dashboard, running on an Nginx HTTP web server in a container within the cluster. And the front-end framework that we use for our application is React. There are several reasons as to why we're using React and why we're using Nginx within this specific model, but these are all mentioned within the README as well as our other design details, design decisions. Let me just go over each of the pages. First page is the login page, which just allows for user authentication into the cluster. OpenShift login integration is a stretch goal, as mentioned previously. But the main purpose of the login page is just to differentiate between administrators who can both view test results and also deploy tests onto the clusters versus viewers who are only able to just view the recent test results. They're not actually able to deploy any tests. So next we have the monitoring page, which is, as I mentioned, available to both viewers and administrators. It displays the latest health checks on each of the nodes, and it does this by reading the node labels using the Kubernetes API, because supposedly Autopilot is supposed to label each of the worker nodes with the latest health check status. And so testing page also uses the same API to read the node labels and show the latest health check results to users. But the testing page, to deploy the tests, has to interact with Autopilot's RESTful API requests, which is specifically designed for deploying health checks. As I'll show later, testing page, you can select a set of tests and a set of nodes and use the Autopilot API to run the tests, the health checks on the worker nodes. So here we have the login page, the user interface. It's pretty straightforward. Then we have the user interface for the monitoring page. Each node, you can expand it. It's an expand box, and you can view the status of the latest health check results. You can also filter the nodes based on status code, search by node ID, etc. Then the testing page is basically similar to the node page, monitoring page, which shows the nodes and the latest health check status. Also includes filters, but also has an additional drop-down menu, which allows users to select a set of tests or health checks to be run on a set of nodes. So they use the drop-down menu to select the test, and they can either click on the nodes or use the filters and then do select all to select the nodes which the tests will be run on.
For the current updates, the team have explored Autopilot and finished the initial setups. These include having designed the global architecture or framework of the project and figuring out how it works. Then we also set a design and an overview for UI for the web application. After this, we worked on the initial setup for the skeleton of the web application. The figure below shows the burndown chart for our first sprint, in which the blue line represents ideal hours, red represents estimated burndown hours, and yellow represents the actual burndown hours, as we can see from the yellow line. The actual burndown hours have fallen below 0, which indicated that the team have spent more time than the estimated work hours during the sprint. This means that the team have decided to spend more time to finish the sprint instead of pushing it to the backlog, where it will go through prioritization again. Next, I will be discussing our next steps for the second sprint. Going forward, the team have planned to utilize vertical slicing. This divides the project to ensure that each sprint results are in working demonstrable software. As a result, most required features for the user are fulfilled before implementing more additional features, which is known as horizontal slicing. I'll now go through to the details of our second sprint. So aside from getting access to the Kubernetes from our mentors, we will be working on the login page, monitoring page, and testing page. For the login page, we will be setting up the front-end components and connection to the Kubernetes cluster authentication. As for the monitoring page, we will not only display real-time node status and health check information, but we will also implement expandable boxes for displaying detailed information for each node, as well as a search box for a quick search on nodes that are based on their IDs. Lastly, the team will do the following for the testing page. They include the drop-down feature to select types of health checks, implementing a feature that enables selection of group of nodes to run the tests on, as well as calling the Autopilot's RESTful API for test runs and displaying these results to the user. With this, we are concluding our demo for our first sprint. We are ready for any questions and feedback. Thank you so much for your time and attention.